Alright folks, in this video we are learning about writing the equation of the altitude. So, when I'm writing the equation of an altitude, just like the perpendicular bisector or the median, I need two things. I need a point, and I need a slope. Why? Because if I'm writing my equation, I am writing it in point-slope form. Y minus y1 equals m times x minus x1. M is my slope that I need, x1 and y1 represent the point I need. Alright, so in an altitude, my directions will likely say something to the effect of write the equation of the altitude from, and it'll give you a point. That point will represent one of the vertices of your triangle, a vertex of your triangle. That's the point we need to use. Use the vertex that they give you. For example, find the altitude or find the equation of the altitude from point A or from B. I would use point A or I would use B. The second one is the slope. The slope is a little bit more challenging. Remember what an altitude is. If I'm talking about an altitude of a triangle, it starts at a vertex, that's what this part is here, and it goes to the opposite side and it's perpendicular. So I have no idea what point it's going to over here on the opposite side. I just know it's perpendicular. Why is that important? It's important because I know the ordered pair of this segment. I know these two ordered pairs. I'm going to find that slope and use the perpendicular slope to it. I call that the perpendicular slope of the opposite side. So I'm going to use these points to find the slope of this third side of my triangle, and then take the opposite, reciprocal, use that slope, this point, in my point slope form. Alright, so let's skim through these examples and go to one over here. So it says the vertices of a triangle are A is at 2, -2, B is at -8, 12, and C is at -1, 3. I'm going to just draw that up here. It doesn't really matter what it looks like. If I call this point B, that's at -8, 12. I can call this point C, and that's at -1, 3. And I could call this point A over here somewhere at 2, -2. Just like with the median, I'm not going to draw the full triangle. I'm going to draw a dashed line for my triangle because I'm just really not that interested in the triangle in whole. What I'm interested in is in part A, what's the equation of the altitude from A? That means start at A and go perpendicular. Now, this one's a little bit funky because my altitude actually would be outside my triangle, which is okay, because this point does not matter. What matters is this point. That's the vertex. A is the vertex I need to use. That's 2, -2. Right now, I could go ahead and get my equation started. It's going to be y plus 2, because my y coordinate is -2, equals the slope, which we have not found yet, times x minus 2. Minus 2 because the x coordinate is a positive 2. So, my slope. I don't know the slope of this segment, but that's what I need. What I do know is I can find the slope of this third side of segment BC. So I'm going to find slope of segment BC. That's the side opposite my vertex. In doing that, I use -8, 12, that's point B, -1, 3, that's point C. If I do 12 minus 3, I get a change in y of 9. So I know my slope is going to be 9 over. I did top minus bottom, so I'll do -8 minus -1. That's the same as -8 plus 1. That's -7. There's my slope. This represents my opposite slope. 9 over -7, or just -9 over 7. That's great, but that's not the slope I use. Because an altitude is perpendicular to my opposite side, I use the perpendicular slope. Perpendicular slope is the opposite reciprocal. This slope has a negative, which means this slope will not. That's the definition of opposite. One has a negative, the other does not. No, it doesn't have one anywhere. This is going to be completely positive, and I flip my fraction, so it's positive 7 over 9. That's what goes in here for my slope, and I'm done. So quick recap. I use the vertex as my point. I find the slope of the opposite side and take the opposite reciprocal. That gives me my point and my slope to write my equation in point slope form.